Hello everyone, and welcome to the Introduction to React course. I'm Giuseppe Maggiore, and today we're going to talk about promises, or rather, asynchronous code. As you know, web applications don't just live in the client. For example, the process by which a user actually logs in, so not just the front-end implementation we've seen in the previous lecture, but actually a realistic implementation of logging in, requires validation back and forth to a server. But here's the thing that makes this interesting. Validation from a server is not instantaneous, because it might take a few milliseconds in the best case, but a few seconds or even minutes in extreme cases when the network connection or the processing workload is very high. But also, it might never complete. It might result in an error, it might result in a timeout, etc. So, when an operation takes so much time that between its start and end, a lot of other computation has potentially taken place, we speak of asynchronicity, or different timings. And in this case, we need to take care of what happens when we start such an operation, what to do while the user or the system in general is waiting for the operation to complete, and also how to process successful results, but also failures and timeouts. So this is very different than calling a function, and given that the systems we build in React are by nature heavily concurrent, heavily asynchronous, we really need to learn how to think in terms of async and await. Okay, now, what we're going to do today is we're going to extend the application we built so far by first adding an asynchronous login mechanism, and then we're going to get the products from an asynchronous API. Even though we don't have a server that can properly validate a username and a password combination against, let's say, a database of users, we can always define local mocks or fakes of our API. And I argue for a focus on front-end development, this is even better than trying to have a server, because we don't have to screw around building an actual backend, because that is, that's going to be a separate course in the academy even, and that's a big concern. It gives us a little bit of freedom to implement our front end while still implementing it in a realistic way, because the login system that we have right now is irresponsibly far from what things would look like as soon as we get a server. But the moment we have API calls that are fake but still look like an actual API call, well, then the moment you get a server, an actual backend, connecting it is easier. Also, we can simulate failures and other edge cases which otherwise would be very rare occurrences during local development. And in general, we can work with more agility and less constraints, especially if the backend doesn't exist or is changing all the time, etc. So, we start by defining what results we expect from the API. And don't worry if this is not exactly the data that comes from the backend. As long as it's going to be possible to later translate whatever the server actually gives us back into what we need, we're fine. So, let's go to the authentication, and I'm going to add an authentication API. Okay, now, an authentication API result will either be, well, success, because there we go, we've logged in successfully, or we have a failure of authentication, and the reason will be one of two: invalid credentials or a generic error. Doesn't really matter what happened. Just either invalid credentials or a timeout, a server was not available, or whatever. For security reasons, it might also be that a login system that's particularly sensitive to risks of hacking, etc., that you get only generic errors, and systems that are even less security aware could give more information, like invalid username or invalid password or generic error. It depends, because if a system, I'm not going to automatically assume that a system should always be super hardened and always give generic error, because otherwise a hacker might try to, first find a username, because then you try a bunch of usernames until you get invalid password. So you keep trying a random username until you stop getting invalid username, and then you start trying the passwords, etc. It depends on the kind of data that the system uses, whether or not we have two-factor authentication for the extra security, etc. So wisdom is in the business context, as always. All right. Then I'm going to create an authentication API object. So just like we did with the operations and so on. So the authentication API, we have a login method. And what does the login method return? It returns a promise of authentication API result. But of course, login, well, as you can imagine, what do we get as input? We get an authentication state. There we go. So we pass the authentication state from the React application as the user presses, go. And let me attempt something, but no, I will do it later. And returns a promise of authentication API result. Okay. In this case, we construct the promise directly. A promise is created by passing it a lambda with, as arguments, resolve and reject, which are the callbacks, very much like the props set state or on delete product, etc. That will be invoked by this lambda whenever we want to either signal that, okay, we are successful, and so you can see that we have to pass to resolve an authentication API result, like kind success, or kind failure and a reason, or we can call reject and pass it, well, whatever we want. Actually, usually this is a string containing an error. Usually, you would call fetch. There's a built-in method, fetch, and to fetch you would pass some information, but for example the URL, so you could say login, and you would pass some extra information in headers, whatever. But we are not going to do it. We're going to briefly touch upon fetch later. Fetch returns a promise anyway, and then you can await the result of fetch, parse it, analyze it, etc. But when we want to build a promise from the ground up, we just construct it with the constructor new promise. Okay. Why is this useful for us? Because now we're going to simulate calls which are slow and which fail with high probability. Why is this extremely important? Imagine you spin up the backend of this application and you fetch to it and you perform a get call or whatever. How fast is that going to be? Well, how fast can communication between two processes on the same machine be? Incredibly fast. There is no network involved. The network is a virtual network literally inside your own machine. The server and the backend and the front end are talking from the same memory, physical RAM and CPU. So obviously it's going to be super fast, and there is not going to be any measurable delay and any significant occurrence of errors. Why? Well, because the backend is always reachable, because there is no margin for errors. And later on you will go live with an application built in such an optimistic environment, and perhaps you're going to forget to build animations that properly give feedback to the user if a login call takes longer, for example. Or you will not simulate error handling correctly, and after you get an error, well, you should either retry automatically or give the user feedback and a button that says, okay, retry now, because this didn't go through, So now we're going to simulate a more realistic, challenging environment like proper network communications. And if we build the application in such a way that it works well under these circumstances, even if your users are using your application from a train, from a car on the highway, in places with bad internet, etc., the application will still work well. So this is kind of a way to increase quality, the quality of what we do. I'm going to call set timeout here, and set timeout is going to wait a random amount of time. Now math.random gives me a number between 0 and 1, and I will turn this into a number between 0 and 4,500 within milliseconds, so 4 seconds and a half. And I'm always going to add half a second so that we always have, even in the best case, half a second of delay, which is going to feel fast enough not to be annoying, but slow enough that if we haven't implemented the transitions properly, we are going to have a problem. We will experience a problem. We will experience what our users would actually experience. Maybe we could tone this down to 2 seconds and a half. 4.5 is a bit dramatic, but let's begin with this. As a good practice, harden your application against worst case scenarios. Okay. Now, again, with a high probability, so 90% probability, or we're going to have the proper response here, so we're going to resolve. And with 10% probability, we're going to simulate a hardcore failure, a rejection. In this case, we just reject without a reason. And here we're going to resolve, but we're not always going to resolve with a successful result. And you will see in a second why this also is important. Now, again, with 90% probability, because random is a value between 0 and 1, so with a 90% probability, a value between 0 and 1 is small equal than 0.9. Okay. In this case, well, we just provide a successful response. Otherwise, we provide a failure because of invalid credentials. There we go. Okay. So, if we call, I'm ignoring the authentication state here, which kind of makes sense because, well, we're simulating things anyway. We could have said, okay, if math.random is small equal than 0.9 and the authentication state .email is part of, I could build a map of fake users. Well, this is nice. It's a nice exercise actually. Simulate a bunch of users like const users, mockdb, and here you could have email, but I don't want to do it right now because this is kind of a trivial. You know what? Actually, no. Let's do this. Let's import the immutable library, hoping that we have it already. Yes, we do. Very good. Okay. And I'm going to create an immutable map. I will set a bunch of emails connected to the related password. So we will have user a at a.a, and the password will be AAA. These are terrible users, obviously, but please bear with me because I want them to be easy to remember. So username and password, username and password. There we go. Okay, we have 3 users. Now, here in the authentication state, okay, I only have the email. I could check for the kind. I'm going to see if I manage to do something pretty. Let me see. Okay, so the kind, we want the kind to be logging in. So I'm going to say this has to be an authentication state intersected with kind logging in. And let's see if the authentication state, yes, now we have the password. Now, refer to the TypeScript, to the introduction to TypeScript course, but here what I'm doing is I'm saying, okay, I want the authentication state, which is either logging in or logged in, and intersect the authentication state, which can be 2 options, with this kind here. And by intersecting it, I'm kind of forcing the kind to be logging in, which means that we also need to have a password, which will also give a compiler error whenever we attempt calling login without having performed a reasonable check on the authentication state, because it doesn't make any sense to call login. Doesn't make any sense to call login if we're logged in already, because we have no password to check. Now, I'm going to take the user's MongoDB, check if we actually have the authentication state.email in it, and if this authentication state is equal to the authentication state dot password, because getting the entry corresponding to the email has to be equal to the password, and this actually is not needed because get will give us undefined, and undefined is not going to be equal to the password that we have been provided anyway. So we can just skip the check for having the entry for the email. Okay, now we have to now extend the state of the authentication with some extra information, because now the current state is not just logged in or logging in, but we might also be waiting for the response from the API. Waiting for API. There we go. So this way we can show a little spinner, or at least prevent the user from clicking login many times, because if you click once, we should transition to the waiting for API state of the authentication state machine, and use this information about the fact that we're waiting for the API in order to control what the user sees. For example, a message saying, hey, I'm working for you, I'm doing this. And also prevent unnecessary or unwanted interactions that might flood the server and land the application into an invalid state. We might also show here an optional validation message that comes from the API, because, well, we're logging in, then we're waiting for the API, maybe there's an error, and then we could show the error and store it in the validation, but we're still in the logging in when we go back to the logging in state, and obviously the login form state never changes, we never drop it. Okay, very good. Now, well, well, we don't go from logging in to logged in anymore. Then we go from logging in to waiting for API. Now, actually, this will do in a moment. This will do in a moment. Okay. Yeah, not that it matters that much. No, let's actually implement the transitions properly. Okay, now, so for that, we now have a new state, which is the initial. It's kind of too verbose as a name. We're going to change it. Initial waiting for API, and this does get email and password, and optionally a validation error. Yes. Okay. And the kind here will be waiting for API, and the validation will be the optional validation error. Okay. I'm going to remove initial. This is not just initial. This is just the name of the state we're building, and this will be just logging in, because logging in authentication state is kind of redundant with respect to the fact that, yeah, where are we in the authentication state anyway? And this will be, well, also not initial because it's a constructor, so that's kind of implied, logged in. There we go. Okay. Refactoring is important. Whenever you see something that feels a bit iffy, don't be afraid. Go for it. It's good. Your code base will be thankful. Okay. Now, so we go from logging in to waiting for API. So this is the only transition possible. And we're logging in. Yes. And we move to waiting for API. We want to have the current authentication state email, the password, and also the optional validation. Yes. Now, no, not really. The validation we lose in this case, which, if you think about it, kind of makes sense because, well, if you call the API again, then we will get a new round of potential validation errors. The previous ones, they can just be deleted. From logging in to logging in, yes, so this is just logged out, okay. And finally, well, yes, not very finally, yes, actually, so from waiting for API to logged in, now, we have to be in the waiting for API state. This email validation, oops, this fake email validation is not needed anymore, by the way, because we have a more solid validation now. From waiting for API, we go to logged in, and we only provide the email. Okay, now this is not doing the API call yet. These are just the state transitions that can be called by the system that's going to run the API when the API gives us a proper answer. Okay, almost there, almost there. All right, now, when we click on the login button, so here, okay, now the first bit actually makes sense. So what do? We set the state from logging in to waiting for API. So this makes sense. We go to the intermediate state. Then, in the authentication API, oh, why is it not happening? Let's take a look. Is it exported? Yes. I was expecting login to be available. Oh, a curly bracket too many. Okay, no worries. No worries. Okay, we call login. Notice though, if we just try to pass the current authentication state, we get an error. Why? Well, because this thing requires the state to be logging in. Let's perform a check. If the kind is not logging in, we just skip. There's nothing to do. Otherwise, this is mildly disappointing. Oh! No, wait. If the guy is logging in. Let me see if I can salvage this properly by splitting the last case. Let's have two of these. One will be kind of logging in, validation, and the other will be kind of waiting for API. Ah, yes, okay. The two definitions are identical, but TypeScript needed the little nudge to find out that, okay, if we check for logging in, then it's not waiting for API. It was a bit confusing for TypeScript. Okay, that's life. I do, by the way, prefer the guard with return. Removes some indentation, which in this case doesn't really carry a lot of information. Okay, so now we call login. Okay, and this is where things become interesting. So login being a promise, and from this moment on, it doesn't matter that the promise is a syntactic promise or it comes from fetch. What we do here is the same as it would be in any case. So even if we had a proper backend with a proper server, this code here, this client code would look the same. Okay, so then we get the login result in a lambda. And now we have to check the login result and see, okay, if it's a success, okay, we logged in successfully, so we set the current authentication state to authentication state, dot operators, dot, okay, so we are waiting for the API, at least this is what we expect. If we're not waiting for the API for whatever reason, then it's good. We don't really want anything to happen, but otherwise we go from waiting for API to logged in. Otherwise, we go from waiting to API. We're missing a transition in the state machine because when we're waiting for the API, there's an error. We go back to logging in. So from waiting for API to logging in. And also logging in, by the way, should accept an optional validation parameter because we want to be able to still show it. Okay, very good. So waiting for API to logging in. Here we want to be in waiting for API, and we create a logging in state with current authentication state dot validation, because now we do want to save the validation so that as the user types the new email and password, they still have access to whatever error the system sent us back. Okay, and so here we can go from waiting for API to logging in. All right, very good. Whew. Of course, a promise might fail, and in this case we get an error, which I'm going to ignore here because we also know our system is not really providing proper errors. And in this case, yeah, again, I'm going to move back. I'm going to move back to logging in. Only thing I'm wondering about though is that no, this one. No, the validation is not as we wanted. I'm going to get the validation first. Because in this case there's been an error. We are certain there's been an error. So I'm going to skip whatever is stored here in the current authentication state. And now you see there's a complaint. Because obviously this thing needs to be an updated of authentication state. And now it requires first a parameter which is going to be the login result dot reason. Yes, and the reason will become the issue. And in this case, where we don't really have a formal reason, I would say yeah, generic error. There we go. Okay, or API error, whatever. Doesn't matter. Now, though, what if the current authentication state is waiting for API? Well, in this case, what we're going to do is we're going to just show a message prompting the user to simply wait. So logging in, and nothing else to do. So there are three states: waiting for API, logging in, and in the last case we have logged in. Let's also make just one very quick check. Okay, so you can see that the kind here is logged in, so we're not accidentally ending in this case while waiting for the API, as was the previous case. You might also want to add some mild distinction. For example, look, yeah, we might say that here, instead of just getting the user which has the same email field, I could do it slightly differently. And look what happens. Then I have to initialize the user with email. And here, and of course, I need to change. Okay, let's ignore this for a second, because I'm going to undo this. But this is slightly more defensive programming, because look at this case here. We don't want to accidentally end here without a compiler error in case we forget to manage one of the states, such as the waiting for API state. So now, if we forget to make an exhaustive check here when we get an issue, and there's no email, and there's no email because well, we have to check. And the moment we add the check, then email is not accessible, but we have to go through user. For the purpose of this course, this might be a slight overkill. In real life, I would strongly recommend making the structures, so in this case, the structure of the authentication state, rich enough to create proper disambiguation in order to defensively prevent this kind of errors. Because it's not about being good enough that you don't make mistakes. Everyone has a bad night of, where they don't sleep, or a bad meal, or a bad day, or stress, for, you know, for whatever reason. So don't worry, and make your life easier for you in the future, and for other people who might work on the same code base as you. So encode as much information as possible in the structure of your state. Okay. I want to clean this up a bit, because if you remember, our promise to ourselves was that the authentication widget, like any other widget, is not supposed to do business logic. And so, what I'm going to do is I'm going to take this method here. I'm going to extract it to a function which I'm going to call invoke login API. And I'm going to move this. Well, I'm going to move it to the state, of course, because this is state manipulation. And I'm not going to put it in the updaters because it's not an updater, it's an operation. So operations. And here we shall have the invoke login API. I don't like the fact that it takes authentication props, but you know what? We'll manage. Okay. One slightly funny result is that there is no direct dependence from the authentication API, which actually, honestly, if you ask me, I really appreciate. Okay, so from the operations we call invoke login API. Very good. Now this thing is clean again. Okay, now time for some debugging. Okay, let's put something wrong. We're waiting. Okay, this is promising. Oh, okay, there was an error. We're not showing errors anyway. But let's see in the authentication, oh, we got a generic error. Let's show the error. Why not? So here we're logging in, right before the button. If there's an error, so props dot current authentication state dot if we have validation, so if the validation is not undefined, then I can put validation error, and then we just put the validation. And otherwise I put nothing, which is slightly better than you know, putting an empty paragraph. If we have no error, then let's just keep this this bit of the DOM. Okay, let's try again. No. Okay. Let's try again. Now the waiting time is kind of, oh look, validation error, generic error. Okay, this is very nice. A at h.a, and then the password is wrong. Logging in. Okay, we're getting a generic error. No. Ooh, our mock API is wrong. Let's fix it, let's fix it, let's fix it. Haha, no, this should not be here, obviously, on top of the if. This is simply the reason that determines whether or not we succeed or fail because of invalid credentials. Okay, next try. Okay, so let's put invalid credentials, and we get invalid credentials. Okay, very good. Let's put some correct credentials. Now we have to wait. And we are logged in, and you can see all of a sudden we get the editing interface. Whew. Okay. So, first of all, well, it's been a bit of a machine gun shooting code at you, but I would like to point out that thanks to this clean coding principle, where we're working in a very structured way by splitting things very neatly, it's very hard to make mistakes. And I said it many times. I know that a lot of people would like to hear the sort of Instagram mentality of, oh, everything's going to be alright, nothing takes any effort, just download the React query, it's going to save you. It doesn't. The thing that saves you is knowledge, understanding, and structure. We deal, as software engineers, we deal with structured information. If our code poorly reflects the structure of the underlying domain and information, then it's just bad code. That's it. That's life. On the other hand, yeah, this feels kind of magical. Like, I've been talking for what, half an hour now? I don't know. I think about half an hour. And we ran the code once, and it just worked, minus this rather minor mistake, actually. And this is not because of any special talent that I'm putting on the field. It's just I'm very structured. That's it. All right. Now, and in order to be even more structured, we're going to split this off into 3 smaller widgets. We're going to split this off into 3 smaller widgets because, well, because honestly, this thing is doing too much. I'm actually going to start with only one. I'm going to move this to a new file. Whoa, what have I done? What happened? Oh, authentication. This is okay. No, that's nowhere near what I was planning on. So okay. Well, this would be okay as a constant actually, but let's extract it to a function. Let's say waiting for authentication, waiting for API. Okay, and let's move this. Let's turn this into a proper component. And this doesn't need any props actually because this only renders. At least I can invoke it like this. Oh, there we go. Yes. Okay. And now I can move this to a new file. And yeah, it's okay. I can just call it authentication. I can just leave it here. Refactoring these is a little bit tougher because, well, the authentication props are different because the types are different. I'm just going to set this up, but I'm not going to finish it. I will leave it as an assignment. So this is the authenticated state. And there it goes, authenticated state. And this is the logging in state. And logging in state. And finally, this is the waiting for API state. And every one of these, in order to split properly, would require its separate props, and should be moved, you know, to a separate module with a separate folder. So here we would have waiting for API. This would need, you know, its properties, its state, etc. Maybe trivial, but extremely important. So don't underestimate how essential it would be to do this, and do it as an assignment. All right. Okay, we will now extend our use of asynchronous calls to the other very classic scenario. We will load the products for the overview with a promise that simulates getting them from the server. So, just like we did for the authentication API call, we are going to start by setting up the mocked API call. So we do things bottom up, so that this bottom-up approach is what I mean by being structured. Like first we set up the data, and obviously the APIs are part of the data because they define how the data flows into the rest of our system. So you have API, then state, or almost at the same level, then you have the updaters, then you have the widget, and the widget might require more updaters and operations, but that's for later. And if on the other hand, you start like a lot of people, we're just mocking the rendering, you know, like, oh, what's it going to look like, and div, and paragraph, and article, etc. You end up doing things that you might have to redo, because if you don't have the data, or you have a kind that requires rendering things differently, etc., you will have to redo a lot of things if you do them top-down rather than bottom-up. So very important to always work bottom-up, because this ensures that you don't try to put the roof on the house before you finish putting the walls, and you don't start working on the walls until the foundation has been properly dug. Okay, so without further ado, let's go to the products. And well, we do have the sample products, okay, very good. And so here next to the products, we will define the products API. Okay, what will the products API do? Just like for the authentication, API, we will need an API result definition, and we will need the authentication API. This might actually be moved to the mock users if we want, or not, more in line with the structure for the products. So good that we checked it out so that we can actually maintain things as similar as possible. Okay, now we will have the products API result, the products API result, yes, and then we have the products API for the products get all API result. Okay, very good. Now the products API has get all. This doesn't require the state because we just get the products. There is no dependencies. This is just something we do as the application starts up. And what is get all going to do? Well, we might be lazy. There's nothing wrong with being lazy. And we might just copy this structure because it's going to be exactly the same. Well, almost exactly the same. So with a high probability, we are going to return, oh well, of course. Now here there's never going to be a reason actually, so we're going to keep this simpler. But when there's a success, we actually do get the products. Let's take a look at the structure in which they're supposed to come in here. And the structure, yes, okay. We're going to get the sample products exactly as they are in our fake database. So there we go. Of course, we need to get the product state. Yes, all right, very good. And when we resolve, of course, we need to provide the response object, which is going to be a success in this case, and the products will come from the sample products. So there we go. Of course, we need to import them, and here we are. Okay, now I'm going to make this a little bit faster because 5 seconds is kind of on the boring side. Maybe even 1500. Well, these 500 seconds are 500 milliseconds are very important because this gives us the initial little delay, so things never happen instantaneously, and this gives us a smaller, more realistic bandwidth of possible delay. Okay, notice that I'm not giving the kind failure anywhere. I should probably give it here, but you know how to do this, and as long as we No. I'm not going to be lazy. I'm not going to be lazy. Being lazy is bad when it comes to simulating error and boundary conditions. Kind failure. There you go. Make sure you get to see errors when testing your application. So otherwise, that kind of code never gets tested. And if it never gets tested, it's broken. 100% guaranteed. No alternatives. Now we need to extend the product state. Because we don't always have products. We might have no products because, well, they are unloaded, or they might be loading, or there might be an API error, or we might actually get the map of products. All right. And what is good about this type definition, and I would really like, oh, no. Well, this thing should get a name. So export type products state, because we're going to use it in a couple of places. Okay, what is particularly good about this type definition, despite the fact that I'm not using the kind, but the kind is not necessary, is that it forces us, so not only me right now, but also myself in the future, who probably will have forgotten the original intention, so I'm guiding myself or other teammates who will have to work on this code base to check the product state and to do something meaningful whenever the product state is, well, not loaded yet, or loading, or in an API error kind of state. We'll also decide, okay, unloaded doesn't exist because we start loading right away. That's also a possibility, as long as I encode this information in a reusable piece of state. Now the product's properties will be just the product's state. And now we can go to, oh well, the main content state is actually the place where we have to adjust this. There we go, product state. Now, you can see, and it makes perfect sense, that the updater for the products doesn't automatically have the map, because the product state might now be loading, API error, etc. We might, emphasis on might, say, okay, if we are in API error or we are in loading, then return the same state, because we can't do much. Otherwise, perform this whole thing. And any operation that requires a map actually has to perform this check. But there's a better way. I'm going to show it immediately. Let me add a utility, and I will put it in the products state. So export const products state. Here we will have just the operations, and one of the operations will be called only if loaded. This takes as input an updater over our map, and returns an updater over the whole product's state. We don't have updaters imported yet. Or products state. Okay, that's okay. So I get the current state. I check whether or not the current state is loading or API error, and if this is the case, well, there's nothing to do. Otherwise, I invoke my updater over the current state, which is a map, and then I return the new map, which is a valid product state anyway, so this updater has been implemented. So the check is only when going in or going back up from a map to a product state is perfectly safe. Okay, now I'm going to embed this little transformation here in a product state, operations, only if loaded. Here I can pass an updater over the whole map, and look, here underscore, so this lambda here will only be called when the product state is a map, and the underscore will actually be the rightful map. I can put this little wrapper around all these lambdas, and now with minimal effort I have extra structure, and I have also produced the tools to manipulate the structure safe and soundly. Oh, no, I put it around the wrong block. Okay, so this is where it opens, and this is where it closes. Yes, because here in the product, we also have to check whether or not the product is available. Okay, very good. Now, so we have made our main content state now smart enough to be able to manipulate this new polymorphic type of product state. Let's add an invoke API to the main content state, just like we did for the authentication. So in the authentication state, if you remember, we had in the operations an invoke API thingy. So here we will have in the main content state invoke get all products API. What are we going to get here? We're going to get the state, which is going to be a main content state, and set state, which is going to be a function that takes as input an updater of main content state. Let's include all this. Oh. Why is it unhappy? Oh, of course, and this function doesn't really give us any information. Okay. All right. So now, if the products, so when we invoke this API, we don't want to invoke it if the products are already loading or already loaded, because that might be a mistake. Well, if they're loaded, it might be acceptable, but for now I'm going to be very conservative and only accept accept that the state must be in API error. So the products didn't load. But for this, actually, you know what? I'm actually going to put unloaded. Let's model everything. Yes, much better. Yes. Let's be very explicit about all the possible states. And unloaded, that's the initial state. It makes perfect sense, and we should respect it. We shouldn't be lazy. Skipping a state never gives us any advantage. So if there's an error or we are in an unloaded state, then it's time to, first of all, set the state. Set the state, and we want to replace the products. Main content state updaters products, and we want to replace the products with loading. So we're going into loading mode, and this will be a products state, because here the type inference doesn't know whether or not this is just a normal string or it's a more constrained string, so it makes a sort of bad assumption saying, okay, it looks like a string, but here I'm going to say, no, you're a products state, so you can only be unloaded, loading, API error, or the map we want. So here we set the products to loading. Then we can call the products API. Oops. We can call the products API, which we also need to import. Very good. We call get all, no parameters. And now we have to catch, and we have to then. Always remember to catch, because well, we want to be able to manage error situations. Well, if we need to catch, it's actually quite easy. We just replace the whole state with an API error, and that's it. Then here we get the product's result, whatever, just the result. And well, let's check the result, because if the result is failure, well, then I have to set the state again to API error. It's a different way of getting an API error. Now, in this case, the server did give us a response, but the response, for whatever reason, for example, we weren't allowed, or the database was down, whatever. So the server managed to give us a response, but it can't give us the response we want, and that's why we produce an API error state. Otherwise, finally, what do we put in here as products? We put result dot of products, which we now need to convert identifiables to map. And oh, still not happening. Oh, of course. Well, because this is not an updater, it's just a new value. I'm still unhappy. Let's hammer this. Let's hammer this into compliance. Now, whenever I find myself confronted with a weird type error like this, not weird, not very weird, I just go back to basics. So, first of all, let's see what type this has. And this is a map of string to product. Okay, this kind of makes sense. You know what? I do have a very strong suspect as to what is happening. I also, in this case, probably need to just constrain. Okay. So this thing here is an instance of this type. Any instance of this type is also an instance of product state. But let me show you actually an important difference. Okay, so this will call temp1, and this will just be replaced with without the proper type. And let's call this temp2, and this will be replaced with the proper type annotation. Now here, temp1, okay, this is an updater of map string product into map string product, okay? On the other hand, this is an updater of product's state. Well, of course, TypeScript has no way to understand that replace with, which is just generic, it gets a value. What kind of type goes into V? What is V? TypeScript is very conservative. Whatever type, logically conservative. Whatever type came out of this expression. So that expression gives a map back. Okay, good. Then replace with deals in maps. In maps of GUID into product state. Or whatever. But in this case, because we say, okay, you know what? Because we're replacing, so the input doesn't matter at all. So the input we're ignoring anyway. So the input is safe to ignore. And the return type is actually more generic or abstract than the one we're putting in here. But that's okay because the value can be safely embedded. So by putting this annotation, we're forcing the whole thing to be to have a bit more structure. Okay, there we go. All right. So we are getting there. The foundation is laid, all the state transitions are done. There will be errors, but I'm feeling pretty confident that they will be debuggable. Oh, of course, now, well, the compiler is going to rightfully complain because, well, I mean, maybe we don't have products. So let's deal with this. So there's an API error. Then we are going to show that there's an error. So there was an error loading the products. There we go. Let's check. This is the little wonder of if it's unloaded. Let's actually start with unloaded. Now, whatever. You know what? No, we will treat visually unloaded and API error in the same way, because if for whatever reason the whole state gets stuck in unloaded, then we want to provide the user with kind of the same information, also the same option to actually restart the loading process. If the products are loading, then we just show a spectacular splash screen, and otherwise, oh, there you go, compiler error has disappeared. Oh, how charmingly nice is this? In the initial state, the products cannot start as the sample products, but rather the products should start as unloaded. Yes, I almost forgot. This could have been a mistake. Okay, very good. Now though, we need to invoke the API, and we invoke the API inside the useEffect call. UseEffect without parameters will be executed when the component is loaded or mounted for the first time. So we check, or when the component is rendered, pardon. So we check, and if the products are unloaded, then we get the main content state, we get the operations, we invoke the getAllProducts API, where we provide the main content state, and we also provide a set main content state, because this API call will actually need to perform some operations on the state. Okay, there are different variations to useEffect. And, well, useEffect can get a list of dependencies and can even return a cleanup function. We will talk about useEffect further, but for now, know that useEffect, well, if we pass the dependencies, then the code inside useEffect will only be invoked if the component is re-rendered and whatever you put in the dependencies has actually changed. So if useEffect doesn't need to run if some things don't change, then we can just put it in the square brackets, and we can even return a so-called cleanup function, which is going to be invoked when this component is cleaned up, when the component is removed. For example, if you start a timer and you want to stop the timer or close a WebSocket connection or whatever, you can do it in this method here. Be careful, there are plenty of gotchas to using useEffect. So my preference is to limit useEffect to as little as possible, and usually to keep it to the root, in order also to prevent re-renders that we don't want, because just you're doing re-renders because your logic is shifting. But you should always be very careful, because this might trigger extra API calls that perhaps you didn't even want to execute. Okay, now with a bit of excitement. Okay, now there was an error loading the products. Well, that's possible. Let's do it again. There's an error loading the products. And was an error loading the products. I'm wondering now whether or not the probability for loading the products is perhaps a little bit too high. So let's check the products API. Well, no, actually, success should come in 90% of the cases. Okay, well, there is clearly something broken. We always get API error. Okay, this would be live. Now, oh, is there yet another error? Oh, this might actually be the problem, by the way, because whenever the call is successful, because I removed an import accidentally, and this line of code was going to crash because identifiables to map can't run, and this throws an exception. The exception makes us land into cache, and this causes the extraneous API error. Oh, well, there you go. Now we get the loading, and okay, there we go, there we go, there we go. All right, now let's increase the probability of failure. Let's actually make this thing fail 50%. No, even more often. Let's make this thing fail 90% of the time now, because I want to give the user the ability to get themselves unstuck. Namely, if there was, well, if for whatever reason the state has stuck to unloaded, then what I do want to show is I want to show a button that makes it possible to invoke the getAllProducts API again. So instead of, okay, so we showed there was an error loading the products, and we also create the possibility reload products. And here in onClick, there we go. Okay, there was an error, reload. There was an error, reload. There was an error, reload. And there was an error, reload. I would like to see it at least succeed once, you know. This would bring me some peace of mind. Yes, oh, there we go. There we go. Okay, so now we have loaded now we have the products coming from an API, and our system has been built in such a way as to be resilient. As boring as it sounds, it's very important to make sure that you do test your application with the equivalent of a very bad network. I know the browser can also simulate this, but the front end as well. In the front end, you have the possibility to simulate which parts of your application have to behave less reliably, whereas if you do this with just a browser support, you will have the slight challenge that every API call becomes a lot slower and unreliable, and that can make the application unusable or untestable. So here you can say, okay, I want the login to be super reliable, but the products to be super unreliable, or vice versa, and then you can focus on a bit of the application that you're writing right now and study how that behaves. Once again, there are some refactorings needed. In particular, the main content API, the main content has to be properly split. So we have the authentication, and this is good, but the unloaded products widget, the loading products widget, and the products widget itself, these containing the button as well, these all require being cleaned up. Cleaned up. Oh, and by the way, the add product button really does belong next to the main product products widget. There we go. Yes. Yes, all right. And this refactoring would require defining a product state, which we have already, defining the product's props, which we kind of have already, and doing the same for the loading. And this is normal. Now, you notice that as your application grows, the single widgets become bigger and bigger and bigger, and so you have to really consciously and with strong intent decide, okay, I'm going to split them now because this thing is doing too much now. And yeah, okay, it's less than 60 lines of code, so you might arguably wait a bit longer, but it's really not a good idea. So my advice is, like, be really careful with this and keep cleaning things up, because this will have a lot of value and maintain the cognitive load required for working on the application low and comfortable. And you will notice that people are happier to work on this code base, and even after months or years. Well, obviously, code has a tendency to drift a little bit into, obviously, some degree of complexity at the very least, so the complexity can never be taken away. But this complexity can be mitigated and can feel manageable at all times. And this we can attain. So, we've talked about managing API calls. We've noticed that this kind of forces a little extra layer, the layer of managing these decisions between unloaded, API error, loading, etc. So it's funny because it really creates a little shield around the main logic of what the application does when all the data is safely available. We've noticed that there's kind of a pattern. The pattern is good because it makes things easier to fix and to extend without having to reinvent the wheel every time. But you might also be wondering if it's possible to actually capture this pattern, and yes, as is often the case, these patterns, whenever we see them, we have to, swim in them comfortably a little bit until we understand how to properly generalize them, and we will in the Advanced React course. As always, thank you so much for being here. Thank you so much for following the course. I hope you're enjoying it. I hope you're learning a lot. See you soon, and until next time. Bye-bye.